Okay, so step one of my extrusion process is warming it up. And I've already had this warming up for a while. I have it currently set to 190 degrees. I have my fans blowing so that the auto tune can account for the cooling action of the fans. I have not yet put material in because the first thing that I want to do is make sure that the auger in the Filastruder will turn freely without any material in there, because there is molten material in there from the last time I did any extrusion. Now normally I would have it plugged into my electronics box, but today I want to adjust speed using another power supply. So if I had it connected to my electronic box, what I would do is flip my extruder switch here and see if it goes. So I would turn it on, and this the stall board would provide sufficient power to make it turn if it can turn freely, but not too much power if it can't turn freely. So right now it's only pumping out 0.01 amps because it's not actually connected to the Filastruder. Normally that would show 3 amps, and if the motor kept going, then I would just leave it on. If the motor didn't go, then I would turn it off, wait a little bit longer for the material to melt, and then try again. In this situation, since I have it plugged into this external power supply that's variable voltage and variable amperage, I have it, the amps turned down so that it's similar to the stall board, so that I can't break my Filastruder motor again. Done that twice already, so don't give too many amps to your Filastruder motor. But I've already tested this, so I know it's going to go, but I'll go ahead and show you. Basically, turn it on, and it's already set to 12 volts, and the motor is going, as you can hear. And what I'm going to do, once I get my material moving, I'm going to crank the speed up, because I want to try extruding at a higher speed to keep the filament moving, produce filament faster, of course, but also to prevent filament from getting too soft up here, because this pipe, as you can see, that's the pipe that the material goes through. It gets hot up here, right? And sometimes it'll get so hot that the material will get soft as it enters the pipe, and we don't want that to happen. So I'm going to crank the speed up so that the heat is being dissipated by the material as it extrudes. So this is what I'll do to do that. I'll just turn up the speed up to 30 volts, and it should really start cranking out the filament at that point. Now you can see I've got some of the old stuff in there ready to drop out. So that's just what used to be in there. I'm going to toss in some fresh material and get it spooling up, and you'll see that in just a moment. Okay, so I've added a funnel there just to make sure I don't make a mess. Same funnel I use for my grinding process, same scoop I use for my grinding process. I put a little bit of material in there. I'm not going to start it up until I got more, but basically I'll just take a scoop of material. This is PETG pellets from Greengate 3D. Which is a plastics recycling company that makes filament and pellets from unused plastics. And then I dump it in the funnel, and it goes down into the hopper. And once I get a bunch in there, then I will start the process. Alright, so I have my hopper full of material now. It's not a full kilogram, but it's most of a kilogram. 2 pounds, pretty much exactly. So this is going to then be moved through the hopper, through this angled part with an auger bit, and then into the extruder, and then out. And then the first step of my process, which I may or may not be able to successfully get on film here because I'm having to hold the camera, is as the material is extruded, I have to kind of carefully hold on to it and guide it up into the winder, and then get the winding process started. And then make sure that it's detected by the laser and properly winding filament. That can take a few minutes to get that process going, because I also need to get rid of the thick blobby stuff that is the beginning of it. Because part of the process of getting the right diameter for the filament is allowing it to stretch, right? And gravity does the stretching, and without filament to do the pulling, it won't stretch. Right, so the very beginning tends to be really thick. So I usually chop that off, and then I can adjust the temperature to control the diameter, because the hotter the filament is as it comes out, the more it's going to stretch. The cooler, the less it's going to stretch. But I also can't go too cold, because then it'll jam. It's got to be warm enough to flow, but not so warm that it stretches too much. So that's the challenge of this system. But hopefully I can get that moving, and we'll be spooling up some filament in a few minutes here. Alright, so I've turned on the Filastruder, and it's going at its typical speed. Looks like I need to give it a little bit more power. I don't want it to have too much. And then I'm going to turn my auger up so that it's moving. Make sure material is agitated and flowing. And we're going to check to see if anything's coming out. Not really, that's the old stuff. So the material has to go a ways down the pipe before it actually starts providing pressure and extruding new material. So I'm going to go ahead and crank up the speed, and we'll see what we can do. Oh, a little bit more power. Okay. We might need to give it some more warm-up time, but we'll let her go and see what happens. Well, I'm trying not to sugarcoat anything. I haven't broken it, but apparently either I'm running too low of a temperature, which is not likely, or I just need to give more time for the pipe to heat up, because once I got material going in there, it doesn't want to go again. So we'll give it some more time to warm up, and then we'll try some more. Alright, it's been a few more minutes at the same temperature, and pipe feels a little bit warmer up here, so let's see if it moves. Give it a second here. Maybe a smidge more power. Nope. Alright, so let's give it a few more minutes, and if it still doesn't move, then we'll turn the heat up a little bit. Okay, 10 minutes later, and it's been at the same temperature. We're gonna turn it up and see if it keeps going. It's trying. It's going slow, so we can see on our voltage. It's getting some voltage. You can hear the motor turning a little bit. I could probably give it a little bit more power, but to be safe, I'm going to go ahead and hook it up to the control box rather than my external power supply, because I know this will not give it too much power. So be right back. Okay, so now I have the motor hooked up to the control box, so the stall board is protecting it from getting too much power. In fact, if I tell the stall board to give the motor more power than I should, it still won't cause any problems, well, real problems, because the power supply will brown out and the whole thing will shut down, which is what happened when I plugged it in, because I think I had this turned up a little bit too high. So now I turned that back down a little bit, so I should be able to turn on the extruder, and the motor will either go or it won't go, but the machine will stay on. There we go. So it's getting 2.5 amps. I know that I can give it a smidge more without any problems. I can go all the way to 3 without breaking the motor. And it's trying, but it's not succeeding. So I'm going to turn that back off and give it a few more minutes, because it seemed to be moving. So I'm going to give it a few more minutes to warm up. The pipe feels a little bit warmer than before, but not by a whole lot. So I think maybe 10 more minutes will do the trick. If not, then I will turn up the heat a little bit. Okay, 10 more minutes at 190 degrees. And the pipe doesn't feel all that much warmer, but let's find out what happens. It's trying. Slowly. Oh, here we go. You can hear it a little bit better there. Come on, you can do it. Alright, I think I'm going to go ahead and bump the temp up a few degrees and give it some more time, and we'll be right back. I figured I'd go ahead and show you how I change the temperature on this thing. So it's fairly easy to change temperature, but I'll also show you how to set auto-tuning. This is the current temperature, and this is the temperature setting, and that's the current temperature. That shows that it's currently being heated. So basically you just push the up or down button to get this to blink and let you change things. And that shows you which digit it's going to change, so you can move to the side to change whichever digit you want. And it does not roll over. It continues counting up. So if I change the 9, if I go up on the 9, it's going to switch to 200. Or if I go down on the 0, it's going to switch to 190. So I'm going to go ahead and do 195. And then hit set. I still don't know what this part means, but I usually just hit set to go back to the temperature that I set. Now if I want it to auto-tune to 195, then I hold set for a few seconds, and then this is the first setting. I don't know what it means, but basically you hit set 5 times until you get to control, and then you want to switch the 3 to a 2, and then you can press or hold the set button until it cycles all the way through all the other settings. 1, 2, 3, 4, 5, 6, 7, 8, and then that's it. And now it's auto-tuning to 195. So just like a printer, the PID tuner is trying to make sure that it is as close to 195 and stays close to 195 without going too far above or letting it fall too far below 195. And of course I have the fans on while it's doing it to make sure that the fan is accounted for in that process. So I will come back in another 10 minutes and we'll give this another go. Alright, so now it's been another 10 or 15 minutes at 195 degrees, and let's see how warm the pipe is. It's warmer. So let's give the extruder a try. Oh, killed it. Apparently I'm giving it too many amps there. Come back. There we go. Let's try that again. Nope. I think it's because I have all these fans, and it's really only designed to power one fan. So I'm going to turn the fans off. It's only designed to power one fan in addition to, I'm sorry, 2 fans in addition to the motor and the heater. But I've got 4 fans and a light in addition to the fan on the motor and the heater and the extruder. So turning the fans off temporarily, see if it'll let the extruder go. Come on, baby. Let's go ahead and give it that full 3 amps there. Come on. A little bit. Okay, I'm going to pull that knob so I stop messing with it. And slowing down again. Come on! Wow. Oh. It's trying. Got a blue light in there. That indicates that it's at the limit of amperage. If I give it any more, it'll die. So, do I let it keep trying, or let it warm up some more? I'm going to let it warm up some more. With the fan on. Alright, be back in another 10 minutes. This is the real face of Filastrudering. Okay, so as you can imagine, this is the frustrating part about filament that's extruding with the Filastruder. And I kind of have to assume that some of this stuff is similar with other machines other than, you know, giant expensive things that are made for factories. But, so, it's been warmed up for another, 15 minutes. So, it feels about the same. But we're going to turn the fans off so I don't brown out the power supply. And let's turn the extruder on again. That's a little bit better sounding. And now it's dying again. Come on, baby. Why are you being like this? Anything coming out there? Yeah, some stuff is coming out. Dropping down into the garbage. I have that garbage there just for all the droplets that fall out. Oh, come on. And you can see the temperature is climbing because the fans are off. It's still going though. Come on, man. It's taking all the power away from the hopper. Come on. Come on, baby. It's definitely a lot better than before. So. I'm going to give it a few more minutes. While I'm waiting for that to warm up, and the thought just occurred to me that one of the reasons this might be taking so long is because I added the extra cooling unit here, and it is drawing heat, or the heat is not able to warm up the pipe quite so much because, you know, pretty much the fans are keeping this end cool enough, right, that it's not able to basically heat creep up the pipe quite as easily. So it might take me a little bit longer than normal. That's why I bumped the temperature up to 200. But I figured in the meantime I'd go ahead and show you how I get the spool, the proper winder, ready to go. So as you can see, it's turned on. So right now it's in manual mode, and what you want to do is, the first thing you want to do is make sure that your guide arm servo is moving the appropriate distance between the two sides of the spool so that it winds up side to side properly. So for that mode you want to be in auto, and then you basically push the button for which way you want the servo to be calibrated for, and then you turn the dial to calibrate it to that side. Now currently the servo is backwards because it's originally supposed to be this way. In the original Filawinder, the servo is actually turned around that way. So in the proper winder it's 180 degrees, so these are actually backwards until the firmware is updated. So I have to think about it in reverse. I've reversed the potentiometer, but all that does is you know, make it kind of backwards. It still needs to be, the machine still needs to think that the servo is going left to right versus right to left. Anyways, you'll see what I mean in a second here. So when I want to calibrate this side, which is technically the right side of the machine, but it's actually what the machine thinks is the left side, I'm going to hold the left button. Now that moved all the way over there because the potentiometer is all the way here, right? So I'm going to actually set the potentiometer in the middle, push the button, and then while holding the button, I'm going to move the potentiometer until it's just about lined up with the side of the spool. It's kind of hard to see, but that looks pretty close, maybe a little bit. Okay, now I did the left button on the right side because, again, the machine thinks that the servo is turned around, and if I do it, if I calibrate the left side to this over here and then the right side to this over here, it doesn't work. The firmware just gets confused or something, I don't know. So I have to calibrate it backwards until we get the firmware situation fixed. So if you build this machine right now before the firmware update, do it this way. So I've calibrated the left side button to the right side, and now I'm going to do the right side button to the left side, and I'm going to move that over a little bit more. That looks pretty good. And then you want to do the home, basically where the starting position is going to be. So again, I set the potentiometer in the center, press the button for home, and then I want it to start on that side. So that's where I'm going to start it. Because once I get the filament coming out of the machine, through the laser, up into the PTFE, this helps create resistance so that the winding is taut. Put it through there, and then I'm going to tape it to the spool here, because putting it through the hole and bending it doesn't seem to work quite so well for this. So I tape it down as close to the side as I can, and then I start the process. The other part of that process is calibrating the filament in the laser sensor. And to do that, basically we want to be in manual mode, and it's turning because in manual mode the potentiometer is basically a speed setting. So again, the potentiometer is reversed, so all the way clockwise is off. But in manual mode, once you have filament blocking the laser sensor, right, you press the home button, and for the next 5 seconds it reads the filament shadow in the laser sensor. And then when you're happy with it, then you switch it back to auto, and it should start winding correctly. Right? So that's kind of a preview of what's going to happen soon once I get this thing extruding filament. So hopefully I'll be able to show you that. If not, then I'll just be showing you it doing its job. So hopefully the next part is it's doing its job, or me showing you the winding start of the process. Well, I got it doing something. It's not going very fast, but the filament is coming out. I should probably move this a bit further away so it's not being bent like that. But I'll figure that out later. And I don't know why it's still wanting to go so darn slow. Maybe I'll crank the temperature up a little bit more, but it's coming out pretty thin. And if I raise the temperature even more, then it'll stretch even more. So, you know what? It's just kind of frustrating. We'll figure it out. Alright, now that I started a video, let's see if it craps out again. I've been playing with extruder speed, and I ended up taking all the material out, and I have it at 220 now for the temperature. I can't go full speed extrusion because the fillet winder actually can't keep up. The gear ratio is such that at full speed it can't keep up with the extruder at 30 volts, which is more than twice the speed that is provided to go at. But you can see the material coming out there. It's last time I looked, it was about, oh, now it looks like it's getting a little bit thick. So I might have to slow that down a little bit. Because it's actually having a hard time being pulled through the PTFE here. So, let's see how bad that is. Yeah, 1.9. That's a little bit thick. So, I might have to slow that down even more. Because I turned more fans back on. So, I think I'm going to have to up the temp a little bit more. So we'll go to 225. And now it's probably going to jam on me. But, yeah, we'll let that go, and I'll see if I can tweak it in a little bit more. Yeah, and I'll pop back in the next time something changes, I guess. I'll be honest. It can be frustrating. As you might have already noticed, that's a different spool. I've had to change the spools 3 times already, because at some point, for some reason that I'm still learning, the filament will just start to get really big, and it will get so big that it will get stuck in this PTFE. So that's probably, 2 millimeters inner diameter. So anything slightly bigger than 2 millimeters will get jammed in there. And so then I have to cut it there, pull the spool off, pull what jammed out of there, stop the extruder. It's going to start just kind of glooping up, swap the spools out, start the extruder again, and basically start the entire process all over again. Make some adjustments, and hope that the adjustments that I made at least gets me filament that doesn't get too large to get stuck in there. So, for that reason, I'm erring on the side of small, which worked fine before, but I don't want it too small either. So, anywhere between 1.6 and 1.7, I'm a happy camper. If it's a little over 1.7, obviously that's fine. When it starts to get bigger than that, then I start worrying. I've unplugged fans to reduce cooling so that it stretches more, so that it stays thinner. It's still warm over here. I feel that it's still warm. So I'm tempted to rig up some additional cooling on the filament path somewhere. Obviously something adjustable so that the filament can move through it and cool without being obstructed. The proper winder is pretty damn good. I'll be honest with you. It was able to pull filament that was oversized so hard through the PTFE that I actually had a hard time pulling it back out. So, yeah, that's a sturdy as hell winder. I've got my temperature up at 230 at the moment, and I've turned it back down to 12 volts so I could actually plug this back into the main power and be fine. Because it seems like, although extruding faster extrudes faster, right? So I could process more filament in a shorter amount of time. It also seems to make it harder to get more consistent or smaller filament. And I'm sure, all of this stuff interacts, right? The voltage and therefore the speed of the auger, the temperature of the hot end, the number of fans and how fast they are going, and how cold the air is that they're pushing in there or pulling in there. How fast I'm winding it, how well that's calibrated. Just all of this stuff plays a role, right, in the consistency and the diameter of the filament. Oh yeah, the nozzle size, or the die size, of course. I drilled that out to, I forget how many millimeters I drilled. I just found a bigger drill bit than 1.7, so it's probably like 2.1 millimeters or something like that for the die, because I wanted it to be oversized so that the stretching could, I could do it at a higher temperature and have the filament stretch and reduce size. So, but that's not something that you can easily change, right? If I wanted to change the nozzle size or the die size, I would have to tear this whole thing down just to be able to get the nozzle off. And then, do I put something smaller back on? Do I drill it out even bigger? What do I do? So, this is not something for somebody who's just into 3D printing. I feel like I'm inventing this thing sometimes. So, yeah. So there it is. Being honest. Not for the faint of heart by any stretch of the imagination. Not as perfect as I might make it seem to be sometimes. Can I print with this filament? I have no idea. We'll see. Let's get a width reading. I'm also gonna make a real-time diameter readout at some point. So let's see what we got here without causing problems. 1.4, and it felt soft. Yeah, it's soft. So it's not 1.4. It's like 1.7, and then I smooshed it. So yeah, more cooling. On the way into the winder or something. I don't know. I'm working on it. I'm just gonna let this go until it dies again or gets stuck again, and then we'll, I'll empty it out and, do something else. So, yeah, there we go.